right, so hopefully you guys are feeling like pros at this. We have our decimal multiplication, right? My 5.83 is closest to 6. And then this one's a little bit weird, right? Because I have a number here. Think of this as like six groups of, and we're going to round this as if it were dimes, right? So as if that were dimes. So there's my decimal. If I have six groups of 10 cents, right, I'm going to have like 60 cents, right? So don't freak out when you see decimals. You got this. Okay, let's do the actual calculation now, okay? Okay, so when I write this problem, I definitely want to keep it that way because these two numbers on the bottom tell me I'm going to have two add-ins, okay? So I'm going to start on the right. 9 times 3 is 27. So I put my 7, carry my 2. 8 times 9 is 72, plus 2 is 74. Put my 4, carry my 7. 5 times 9 is 45, and then 46, 47, 48, 49, 50, 51, 52. Right? So hopefully you did that. Or you could have done 45 and then break this up. There's a 5 in there that would have taken you up to 50, and then the 2 extra. But I want to make sure kind of showing you. Sorry guys, I don't mean to like count with you. I know you can count. Okay, when I go over here to the 0, right, and I have to do that because I have a decimal here. This 0, I moved over, so I have to put a 0 as a placeholder. 0 times anything is 0, but we'll just go through the motions. 0 times 3 is 0, 0 times 8 is 0, 0 times 5 is 0, okay? So again, it does nothing, but we need to show our work for that. So I put my 7, 4, I'm just adding, I start on the right. Obviously, anything plus 0 is going to be what we started with. Now, here's where it becomes a big deal. I go back and I look after the decimal, and I have 4 places. So I start behind the number, and I'm going to move over 4 places. So there is my number. Now, remember, I said I thought about 60 cents. So we know we're less than that, right? And that makes sense. We're right where we need to be. Okay, let me know if you have any questions. Okay, my integer subtraction. Clearly on this one, you should be able to tell. If I start with 98 and I take 106 away, I'm going to have a negative number. Notice these two are pretty close, so I know that I'm going to be like probably within 10, right? Okay, so that's going to be my estimate. Let's do the actual work then. We know with that, we need to do our keep, change, opposite. Okay, so I'm going to keep my 98. I'm going to change my subtraction to addition, and then this was a positive 106, so it becomes negative 106. Okay, so once I have this problem, now I use my idea, which one has the greater absolute value? Which one's farther from 0? Hopefully you recognize 106, right? And we know that has a negative sign to it. So my final answer is going to be a negative sign. Once I do that, I don't worry about the sign. I put the greater absolute value on top, and I take away that smaller absolute value. This is what we called our stack and solve, right? I was making 98 0 pairs. I was matching my positives and my negatives. Okay, so 6 minus 8, I'm just going to start on the right. Hold on a minute. Okay, 6 minus 8, I can't do that, so I have to borrow. Well, there's nothing here, so I move over. This becomes 10, this becomes 9, and 16. 16 minus 8 is 8. 9 minus 9 is 0. So my answer here is negative 8. And we figured it was going to be within 10, right? Let me know if you have questions. Okay, subtractions. We need a common denominator. Talking through my estimate, 1 over 11 is pretty close to 0. I need 11 in a whole. I only have 1 of them. And then I'm taking away 2/3, which is like almost a whole, right? So we know my answer is going to be negative in this one, just kind of like we did that last time before. So when I'm looking at this, I need my common denominator because I am subtracting. Remember, add or subtract. 11 is a prime number. And also if we look at our multiples, if I skip count by 11, I have to look at, if I skip count by 3, what would I come to? That's the same on each. I want the smallest. So instead, because these are kind of smaller numbers, and 11 times anything under like up until 9, right? Because we have the ones, it's going to be like the same. So times 3 is going to give me 33. And this one times 11, right? Anything times that, and I'll show you what I'm talking about. So 3 times 11 is going to give me 33. 3 times 11 gives me 33. That's what I want because I want the same size pieces. 3 times 1 gives me 3. Now look, 2 times 11 gives me 22. So what I mean is just whatever number you're multiplying 11 by, both digits are going to be that number. Okay, so here's our problem. I have 3 and I'm taking 22 away. I can't, right? So I know I can take away the 3, but then I'm going to have more. So I have more negative here. So I'm going to go 22 minus 3 to see how many more do I oops, hold on a second. Okay, how many more do I actually still owe, right? So 2 minus 3, I cannot do that, but I can make that. I'm going to borrow, make that a 1, make that a 12. 12 minus 3 is 9, and this is 1. So I'm going to have 19 over 33. Negative 19 over 33 because I still owe. And we knew that because remember, when we looked at our original problem, we saw we were almost at 0 and then we were taking almost a whole away. So on this one, I know that that's going to be a correct roundabout answer, right? Now I have to consider, is it in lowest terms? Okay, so I see that I have a 9 in the 1 when I have a 3 in the 1. So I know both are odd, except for I also know if I skip count by 3, the closest number to 19 is going to be 18. So I know 19 is not going to be a multiple of 3. So this negative 19 over 33 is going to be my lowest terms. Okay, let me know if you have questions. All right, our final problem, guys, is our mixed number multiplication. 10 and 3/8. So this is like, remember, half of 8 would be 4. So I know I'm less than half, so I'm going to round this to 10. Times half of 7 is 3.5. So I'm more than half, so I'm going to round this up, and I'm going to get 50. Okay, so my final answer should be somewhere in that ballpark. When I do my mixed number multiplication, I need improper fractions. Okay, so I do my denominator times my whole. 8 times 10 is 80 plus my numerator. So I get 83 over 8. And then I'm going to do my denominator times my whole. So 7 times 4 is 28. And then 29, 30, 31, 32, 33. And that's over 7. Okay, again, I'm going to turn the light off my hand. Don't freak out. You got this. Okay, so I'm going to do my 83 times 33. Okay. And you know what? Let's do it a little bit different way so that you can see another way that you could do it. If I'm taking my 83, I can split that into 80. Whoops, you can't even see that. 80, and I can split, so it'd be 80, and then I'd have 3. And I can do each of those times, right? So if I'm looking, never mind. Let's stick with this one. Okay, sorry. I don't know. It is important for you to see this. What I did was this. So really the 30 should go on top, and the 3 should be here. Okay, so what I'm doing is just breaking this up, and I just did it in here because this is in the 10s, this is in the 1s. So I'm taking the 83. If I do 83 times, and I'm going to do times just the 3, and I'll show you why. If I do the 83 times 3, 3 times 3 is 9, 3 times 8 is 24. Okay, so if 8 times 3 is 249, so I picked the edge to use, right? If I'm doing it times 30, I'm going to keep the same thing, 249. Then I'm going to put a 0 on the end because that was with the 10. Then I'll just add these together. 2490 plus 249. Notice I have to line them up. Okay. So 0 plus 9 is 9. 9 plus 4 is 13. Carry my 1. 1 plus 4 is 5. Plus 2 is 7. And I do my 2. So here should be my answer. This is going to be, and that's important why I did that, guys, is because sometimes you see this and you guys get all freaked out. Okay, so instead, I'm going to do the same thing, though, and I should end up with the same answer. 3 times 3 is 9. 3 times 8 is 24. I'm going to put my 0, which is what happens when I was doing times 30, right? It's a placeholder. Then I'm doing the same thing. 3 times 3 is 9. 3 times 8 is 24. Whoops, I almost read it backwards. And then when I add 9, 3, carry my 1, 7, 2. So there's my answer. So do you see I can do it two ways, just like we talked about before, breaking it up. So this is my answer to the top part, right? So I have 2,739, and I'm splitting it into groups of 56. Not a big deal. If I have 50, I know when I do my 50 times 50 would give me 2,500. So I know that it's probably going to be somewhere in that ballpark. Okay, so we need to do this actual division. Hold on. Okay, so when I look here, I have my 2. I cannot make a group of 56. 27, I cannot make a group of 56. So I'm looking in 273, okay? Because this is almost 60. I'm going to try times 4. Because 60 times 4 is going to give me 240. So I'm going to do this times 4 and see. 4 times 6 is, just like we said, 24. I put my 2. 4 times 5 is 20, plus 2 is 224. I'm going to put that under. And this is 4 groups if it works, right? And I'm going to subtract. If I have 3, I can take 4 away. This becomes 6. 13 minus 4 is 9. 6 minus 2 is 4. 49 is less than 56. I definitely cannot make another group, so that was the correct answer. So now I'm going to bring down my 9. Now I have 499, and I'm making groups of 56. I know that 4 groups of 56 is 224. So I'm going to see if I do another 4 groups. So if this will be 8, right? I'm going to show you. I'm going to do 224. So the answer to this here, so you can see what I'm writing. This is like 8 groups. Let's see if that's going to work. 4 plus 4 is 8. 2 plus 2 is 4. 2 plus 2 is 4. Well, let's take a look. So this would be 8 groups, 56 times 8, and we're going to put that under. We got 448. Let's subtract. 9 minus 8 is 1. Pick it up so you can see. 9 minus 4 is 5. Look how close we actually were. So that's going to be the correct one. We're going to put our 51 over 56 here. Okay, now we have to decide, are we in lowest terms? So I know that 1 here makes it odd, 6 makes it even. So I don't have a common factor. Okay, so 48 and 51 over 56 is going to be our lowest terms. Okay, let me know what questions you still have.